So what I'm going to do today is a two-parameter logistic IRT. IRT is a type of item analysis, and this is going to help me measure the quality of the items that I have. So IRT can analyze how appropriate an item is and how well they measure the latent ability or trait, the underlying ability. So the first thing that I'm going to do is load my packages, and they're actually already loaded, but I'm just going to redo it. So I'm going to library the LTM package, which is for the latent trait models, and the read Excel so I can read the data off my computer. So I've run those, and the next thing, my next step will be to load my data. I'll use the read Excel function, and this is a location on my computer, and I'm going to hold it in the IRT data object. I'm also going to view that same object here. So I'm just going to run all of this data. This loads my data from my computer. So now my IRT data is here in my global environment. It has 637 observations with 5 variables. Over here, I can view the items, and you see that the columns are items 1 through 5. A 0 is means it is incorrect, and a 1 for correct. And so that's just all of my data. So since an IRT can predict the probability of a successful answer, and in this case, the two-parameter IRT uses the two parameters, difficulty, which is the B, and the discrimination, which is A. To give an example, a hypothetical situation of why I would use this, imagine I work for an organization that uses a cognitive ability test for a selection that is intended um, uh, to an applicant that, like to select an applicant with cognitive ability at least one standard deviation above the mean, so that above average in cognitive ability or intelligence, however, whatever side of that argument you're on. But there is maybe some evidence in the organization that this is not actually the case. So the people being selected maybe don't fit that criteria in practice, so that maybe that there may be something wrong with the test. So now it is my task to analyze the items using this two parameter uh, logistic IRT. So I can, which will help me see how difficult the items are and if the test works the way it was meant to. So I'll start by creating my model and set the parameters using the LTM function. The first argument of my model would be I'll be using the IRT data. This is a data frame that holds all my data. Next will be I'll indicate Z1, and this means that I'm using one latent variable. And the last argument of my model that I'm going to use is this IRT.param. I'm going to indicate, I'm going to assign this a value of true. And this is so I can get my values in the BA format, the difficulty and discrimination format. Otherwise, if it was false, it would be in an intercept form, and that's not going to be helpful for me personally. So I'm going to go ahead and run this model. And I know that it has been created because it's in my global environment. So now that I have created the model, I can get values for it using this coefficient function on the model that I just made. And I can also plot it, which I'll do next. But first I'm going to run to get the coefficient values. So here down at the bottom, now I have the difficulty and discrimination values. So these are the difficulty values, or the B values are also known as theta, and these are the discrimination values. So the higher the difficulty, or the B parameter, the higher the trait a person needs to be in order to answer it correctly. This value tells me how difficult the item is, where the participant has a 50% possibility of endorsing the item. These are in z-scores, so 0 is the mean. So from that knowledge, I can see that item 1 and item 3 are very difficult. This item 3 is actually almost 2 standard deviations above the mean. However, items 4, and items 5, they're all negative. They're all below the mean. They're at least 0.5 below the mean. Item 4 is closer, is like 0.75. So not quite to -1 standard deviation below the mean, but these are easier questions. Next is the discrimination and so these tell me how well an item can distinguish between subjects with like high or low standing and the latent variable. So the higher this value, the better the item is at differentiating between the respondents, and the items can tell like the difference between their ability. So I want a number that is greater than 1 at least, and from these values here, I can see that item 1 and item 3 have very low discrimination. In fact, they don't even reach the benchmark of 1 that I have just personally set for myself. These are also the very difficult questions. However, on items 2, 4, and 5, the easy items, their discrimination is very high. So what this tells me is that the easy items, even though they're easy, they're better able to tell between people that are high or low in the latent variable, but they're measuring it at a lower level than the items were intended to measure. Item 1 and 3 are doing just the opposite of that. They're very difficult, but they're not able to tell the difference between the high and low performers very well. So I want to have a visual representation to take this information to my management and to show my team what I found. So I'm going to go ahead and plot this model. I'm going to use the plot function with the IRT model, and the type of plot that I'm going to make is an ICC. This stands for item characteristic curve, and it will plot all of my items at once. So I'm going to run this, and I get this output over here, and these lines represent all of my items. These curves are intended to be steep. A steeper curve, the steeper the slope on these curves indicates higher discrimination. I have ability going down here with 0 as the mean, and then these are standard deviations below the mean and standard deviations above the mean. And then here I have probability. So right here, this is about 50%, and where 50% is indicates the location it is on ability. So again, this is just a visual representation of what I found over here is that items 1 and 3, the corresponding numbers are my items. So items 1 and 3, their 50% is over here. They're very difficult, but their slope is not steep, so they do not discriminate very well. And on the other hand, my 3 easy items, see here at 50%, they're measuring below the mean in ability, but they have steeper curves, so they are discriminating well, but they're not measuring at the distance that I would have liked them to. So I can take this to, this is something that I can take to present to my manager, to my supervisors, and show my team about um, how I'm getting what I found about this test. And my recommendations for this would be that items 1 and 3 just need to be discarded. Items um, 2, 4, and 5 need to be reworked. What I'd like to see are these curves be farther apart so that we're measuring, have a range of measurement here. Is it was what that would indicate is if they were separated. I do like the steep slopes. Um, I'm also going, next I'm going to plot a different type of curve, which is called the ICC, and it's just an item information curve. And I'm going to plot it for items 1 through 5. What this does for me is it shows the distribution of the items. Still down here I have ability, but this, what I would want to see here are more normal curves, and instead of probability, I just have information, and this just tells me how much information and where the information is coming from across ability, just like a normal curve. So I would want these to be more normal. I would definitely want them to be more over to the right. Again, you see that item 1 and 3, they're giving me no information. However, item 2 is giving me the most information, but it's still giving me the most information below the ability that is desired or that the test was intended to. And finally, I'm going to plot again and use the IRT model. This will be an ICC as well, but I'm going to put the items argument to 0, and this will combine all of these curves and show how the test performs overall. I'm going to run this and I get this one curve, and this is the same type of information curve, but this is about the whole test. And again, even with the difficult questions added in there, I'm still getting the most information below the mean, and so that's not what I want. So I'll say again, my recommendations are to go back to my team and tell them that this test needs to be reworked. These items are not sufficient, and they're not, overall the test is not measuring the level of ability that it was intended to measure. So those are my recommendations. Thank you.